Okay, today we're exploring the derivative of trig functions, and the first function we're going to look at is the derivative of the sin x curve. Remember that derivative means when you find the first derivative, you're finding the gradient of the function. So can you see where I am right there? I'll just zoom in. Can you tell at that point, you know how gradient is rise over run? So at the moment you don't know how to differentiate y equals sin x. But the derivative is the gradient of the function at any point. So here I've got the tangent to the curve. Can you see it there? The black line, I'm on the tangent there. That black line, straight line is the tangent. What's the gradient? So this here in brownish color is showing me the gradient. Isn't rise over run 1 over 1? So at that point there, the gradient is 1. So here, if you want to just grab your calculators for a minute, look up here. What's the gradient there? You actually don't even need a calculator to work out that gradient. If it was definitely horizontal, what would the gradient be? 0. So I've got a gradient of 1 and I've got a gradient of 0. Say here, what would the gradient be? Wouldn't it be 0.83 over 1? So what I'm going to do, one sec, actually you don't need your calc. What I'm going to do, gradient here is 1 and then the gradient keeps changing. So what I'm going to do, I'm going to put in green, the dotted green line is the cosx curve. So as I said, the gradient at that first point is 1, isn't it? Right, the gradient, say here, would be 0.93 because, can you see those numbers? 0.91 over 1. The rise is 0.91. The run is 1. So the actual 0.9 is this point up here on the curve. Up here, the gradient is 0. Look at the cos curve. I've drawn the cos curve in green. See, so back down here, the gradient's 1, as we said. Look at the green dotted curve. That value up there is 1. So the green dotted curve is the gradient function. Now, yeah, so up here, for example, the gradient is 0.71. If I actually look at the green curve, that point is 0.71 as well, right there. Here, the gradient's 0, but look at the green function. The value's 0, do you see? So if I keep going here, can you see now my gradient's negative? Look where the cos curve is, negative values for the cos curve. Now, when I get down to here, what's the gradient? What should the gradient be, do you think? You can see that -1. Look directly underneath at the green curve. That value down there is -1. What about here? What should the gradient be right here? And it's 0. So therefore, the gradient of sin x is cos x. Okay? I know it's great, isn't it? And here, what's my gradient? See, because rise over run. Can you see the values? 1 over 1. The gradient's 1. Look at the green curve. Its value is 1. Again, here, up here, the gradient's 0. Look at the green curve, 0. All right, so that shows us that the gradient of, so it's a rule and it will be on your formula sheet. So the derivative of sin x is cos x. Okay, the gradient of sin x is cos x. When for sin x, when x is 0, the gradient's 1, and you can see it from rise over run. If you look down here at this grey bit, that is the 0.01 on the curve. Up here, if I drag the point, for example, the gradient is, I'll just wait till I can see the numbers, 0.8. The gradient's 0.8 because the rise is 0.8 and the run is 1. And if I look down here at point D, see its y value is 0.8. So the y value for D is showing me it happens to be the same as the gradient. So the point on the green curve is the same as the gradient of the blue curve, the y value. All right. Here, for example, the gradient's 0.52. Look here, the point D is actually on the green curve. It's 1.02.52 because the green curve is y equals cos x. So whatever the gradient is of the blue sine curve, that is the y value of the green curve. And if you look here, we know the gradient 0, and that is, they've both got the same x value, but the gradient is 0. It's on the cos curve. We know the gradient 0 of the blue curve, but the point on the green curve is 1.570. Do you recognize what 1.57 is? It's half of what? What's pi? Isn't pi 3.14, 1 whatever? 1.57 is pi on 2. So, okay. Okay, we're going to do the same thing here again. The blue curve is the cos x curve. In green, I've got the negative sin x curve, and I'll show the value as well. So looking here, when looking at the tangent of the sine curve, here the tangent 0. Look at the green curve, it's 0. Also down here, look, I can't get it right there. Okay, so, and the point on the green curve is 0, 0. So when we're doing the tangent when x is 0, okay, we can see that the gradient 0, but we can see the point on the green curve is 0, 0. Tell me now about the gradient. Would it be negative? Isn't this a negative gradient? So what would the value be? Rise over run, negative 0.53 over 1. But look at the green curve. The value on the curve down here is, yeah, negative 0.53, the same as the gradient. It's 0.55. When x is 0.55, the y value is negative 0.53. Down here, we're expecting the gradient to be negative 1, and it is. So the gradient here is negative 1. You can see the rise over run, okay? And on the green curve, you've got 1.57, which is pi on 2, negative 1. Now tell me, gradient's still negative, isn't it? See how the cos curve is still negative down here? And then the gradient here is 0. And so the green curve is not cos anymore. What is it? It's the negative sine. Remember, sine would normally go like that. It's the negative sine curve. Okay, gradient 0. Gradient is now positive 0.66 at this point. You can see that's the same value as what is on the curve. Here, the gradient is 1, so representing that point up there. Here, the gradient 0, etc., representing this point here. All right? All right, so that will be our 2 rules.